In this objective, we created a circuit that controls the speed of the LED in which it blinks. As I will show you, once I turn the potentiometer, the speed of the blinking LED will go faster or slower.
Okay, so every time you see the bracket, it's referring to something else already. I guess those are part of the system.
In the second objective, we updated the code so then it will print out the value of the potentiometer. As you can see, the readout is 493. Once I turn the knob, the LED blinks faster and the value gets smaller. Since we're changing the value of the potentiometer, the speed of the LED blinks faster. Here in the third objective, we get to play with 3 different MEC robotics sensors. This sensor here is a potentiometer. As you can see how it's connected, it has a black, red, and white wire. The black wire is ground, the red wire is the 5 volts, and the white wire is the control signal. That control signal is connected to the green wire, which is the sensor pin that is defined in the code. That sensor pin is then sent through the yellow wire, which creates the blinking of the LED, and this resistor reduces the current flow, which reduces the brightness of the LED. As you can see in the monitor, we have the value of the potentiometer, which is 1023. Once I turn the potentiometer, the speed that the LED blinks increases. And as you can see in the monitor, the value decreases. If I keep turning the potentiometer, the LED blinks even faster, and the value of the potentiometer lowers on the monitor. The second sensor we are going to use is a light sensor from the MEC Robotics. As you can see, the circuit is still built the same, and the only difference is the type of sensor we're using. The black wire from the light sensor is still ground, the red wire is 5 volts, and the white wire is the control signal. As you can see, this is the initial speed of the LED when the light sensor is not covered. From the monitor, the value of the light sensor is around 1008. As I cover a piece of the sensor, the speed of the LED blinks even faster. The value of that sensor is 998. Once I cover more than half of the sensor, the speed blinks faster and the value drops. The last sensor we're going to use is a push button. As you can see, the circuit is a little different. Instead of having the green wire connected to an analog pin, it is connected to a digital pin, which is pin 7. Also, the wires of the push button are different. The black wire is still ground, the red wire has no connection, and the white wire is still the control signal. As you can see from the code to the board, we have labeled pin 7 as an input pull-up, which in turn inverts the logic of the push button. So when the push button is at 1, the LED is off. And when the push button gets pressed, it's 0 and 0 is on. As you can see, when I push the push button, the LED lights up and the value for it is 0.